Hey everyone, and welcome to today's explainer. I am absolutely pumped to dive into this one. We're looking at a fascinating new research paper titled PalmClaw, a native on-device agent framework for mobile phones. Now, if you've ever watched an AI agent painstakingly try to navigate a mobile phone app by literally pretending to be a human finger, slowly tapping, swiping, and then just totally breaking when the screen layout changes even a little bit, yeah, you know the current state of mobile AI can be, well, pretty frustrating. But this paper, it introduces a massive paradigm shift. We're going to take a deep dive into the future of mobile AI today and explore how the researchers behind PalmClaw have completely redesigned how artificial intelligence actually interacts with our devices. Okay, let's dive into this. Here is our roadmap for today. First, we'll look at the mobile AI problem. Then, enter the PalmClaw framework. Move inside the agent components. Check out context and tool execution. Look at setting execution boundaries. And finally, unpacking the results. All right, starting things off with Section 1, the mobile AI problem. Let's get into exactly why current mobile agents are just so slow and easily broken. Take a look at the image on the left here, the one labeled A. This shows the old externally hosted GUI method. Basically, the agent sits on some remote desktop, constantly observing the GUI state, which is essentially just taking screenshots over and over and then sending back GUI actions like swipe or tap to remote control your phone. It's kind of clunky. Now contrast that with the image on the right, Section B, showing the PalmClaw framework. Notice how the external host is just gone? The agent loop, the tools, the execution, it all happens natively inside the device itself, making direct tool calls to local resources. To put it simply, that old way translates to these incredibly long, interface-dependent sequences. Think about it. If an app updates and moves a button, say, 2 inches to the left, the old GUI agent completely fails because it ends up tapping empty space. Plus, the AI can't actually access the raw files or sensors. It only knows what it can physically see on the screen. The PalmClaw way completely solves this by abandoning screen tapping entirely. Instead, it uses fast, native, on-device tool execution. It's just a totally different philosophy of interaction. Which brings us perfectly to Section 2, enter the PalmClaw framework. Let's look at the researchers' elegant solution to all of this. So the real secret sauce of PalmClaw lies in a concept the researchers call device tools. Let's translate that academic jargon for a second, okay? Instead of the AI pretending to be a human finger and randomly tapping a screen, a device tool lets the AI talk directly to the phone's native systems using actual code. It gives the AI explicit arguments, provides structured data back as results, and most importantly, it places strict execution boundaries around what the AI can and cannot do. Now, what's really interesting about this slide is how it maps out the complete architectural flow. It is honestly brilliant. Over on the far left, you've got your inputs, whether that's a local text message you type, a remote channel, or even a scheduled wake-up. These flow into what they call sessions. Each session then pulls from memory. That's both long-term and session-specific memory, and accesses skills, which are basically just reusable instructions. All of this context is then fed into the agent loop, right there in the center, which makes a call to a large language model. The LMM decides to use a tool, sending a request over to device tool execution on the right. Here, PalmClaw checks the tool registry, validates the schema, verifies permissions, and checks workspace boundaries before finally executing the action on your phone's actual resources, like your calendar or your files. It's this beautifully contained, highly secure loop, and it's all happening right on your phone. All right, moving on to Section 3, inside the agent components. Let's break down the specific moving parts making this on-device framework actually function. There are 4 main pillars doing the heavy lifting here. First up, sessions, which organize all your user interactions and keep your chat history separate. Second is memory, handling long-term storage and summarizing older messages so the AI doesn't just forget the context of your task halfway through. Third, we have skills. These are reusable task instructions stored in super simple markdown files. And finally, the tools themselves, which are the actual levers the AI pulls to access your native device resources. The really crucial takeaway here is that absolutely everything, from memory consolidation to session states, is handled directly on your hardware, not on some distant corporate server. To understand just how capable PalmClaw is right out of the box, let's dissect this figure. This visually maps out the specific built-in skills and tool groups. If you look at the categories on the left, under Device and Media, PalmClaw can directly access your Bluetooth. Under Personal Data, it has tools specifically coded to interact safely with your calendar and contacts. But my personal favorite has to be the Workspace section. It has native file operations to list, read, write, edit, delete, and move files right on your device. It can even search the web, fetch the weather, and manage cron jobs for automation. By hard-coding these skills, the AI doesn't have to guess how an app works. It just calls the native function directly. It's so much cleaner. Next up, Section 4, Context and Tool Execution. Let's see how the AI actually thinks and acts in a loop. Let's move to and see how this builds into what the researchers call the bounded multi-round loop. It happens in 3 distinct steps. Step 1 is context assembly, gathering all the system instructions, your history, and available tools. Step 2 is the agent loop. This is where the AI actually reasons through the problem and decides which tool to call. And step 3 is tool execution, where PalmClaw intercepts the request, validates it to make sure it's absolutely safe, and runs the action. This loop is what prevents the AI from just guessing blindly. It acts, observes the exact system response, and then decides what to do next based on real hard data, not just a blurry screenshot. And here we see the context assembly under the hood. Before PalmClaw makes a single remote LLM call, it gathers all these clues. It pulls the system prompt, telling the AI, hey, you are PalmClaw, an assistant inside a mobile app. Then it injects the runtime context, the skills, and the exact specifications of the tools available. By packing all this highly structured native data into the prompt, the AI knows exactly what it is capable of doing before it even tries to solve your problem. Now you might be wondering, if this AI has direct native access to my files and calendar, how do we stop it from going rogue or, I don't know, accidentally deleting all my photos? Well, that brings us to Section 5, Setting Execution Boundaries. The researchers were incredibly meticulous about safety, and this figure proves it by showing us the literal execution traces. Let's walk through case 1 on the left. The user says, add a meeting with Alex tomorrow at 10 a.m. PalmClaw attempts to call the calendar tool, but look at the result. Permission missing, send permission request. It completely halts the execution right there and prompts the user on screen to grant access. Only after the user actively clicks grant does the tool execute and create the event. Now look at case 2 on the right regarding the workspace boundary. The user asks to save a shopping list to the public SD card. PalmClaw tries to write it, but the framework blocks it, stating file path outside current workspace. All files access required. It literally stops, opens your phone's app settings, and forces you, the human, to manually toggle the master switch for file access before it proceeds. The AI is entirely 100% bounded by your phone's native security architecture. No way around it. As the researchers explicitly state in their paper's ethics statement, PalmClaw is designed to keep mobile actions explicit and bounded. Tools are registered, arguments are validated, sensitive actions rely on Android permissions or user confirmation, and file operations follow workspace boundaries. Security and bounded actions are baked into the very core design of this framework. It is absolutely not an afterthought, it is the foundation of the whole shebang. All right, Section 6, Unpacking the Results. Let's see how this actually performs when we put it to the test. 94.9%. That is the massive reduction in average task completion time achieved by PalmClaw. I mean, think about that for a second. Waiting for an AI to complete a task shouldn't take longer than just pulling out your phone and doing it yourself, right? PalmClaw absolutely shatters the speed barrier here. And this brilliantly illustrates exactly what we're talking about. Let's analyze this table together. Look at the very top row, MobileClaw. This is the old desktop-hosted GUI approach. To complete a task, it required an average of 94.3 actions and took an agonizing 1197 seconds. That is practically 20 minutes to complete a single mobile task, with only a 60% success rate. No way. Now scan down to the bottom row, PalmClaw. Because it uses direct device tools instead of pretending to swipe a screen, it only needed 2.8 actions, it took 17.7 seconds, and the success rate jumped to 97.1%. We're talking about going from 20 minutes of fumbling around a screen to 17 seconds of precise native execution. It's truly night and day. But you know, the benefits aren't just in speed, they're in convenience for sure. Look at the deployment data highlighted here. If you wanted to run the old MobileClaw baseline, you needed a separate computer, command line interfaces, a bridging server, and about 15 minutes of setup time just to get going. Claw Mobile took around 25 minutes. PalmClaw, 0 external desktop requirements, no command lines, 2 steps. Approximately 2 minutes to set up. Because the agent lives natively inside the app right on your phone, you literally just open it and start working. So simple. So, what does this all mean? The crucial point is this. We are finally moving past the era of AI acting like some clumsy ghost haunting your touchscreen. PalmClaw proves that native, code-level tool execution on mobile devices isn't just faster and more reliable, it's fundamentally safer because it actually respects the device's actual security boundaries. And it leaves us with a fascinating question to consider as this technology matures. If your phone's AI no longer needs to literally tap your screen, what boundaries will you set for it? Thank you so much for joining me to explore this incredible paper. Keep questioning, keep learning, and I'll catch you in the next explainer.